you know what it's going to be. Okay. So now let's move on, moving forward. And we're going to talk about how we balance these redox reactions. Okay. So there's a special way we have to balance these reactions. Not only do we have to balance the atoms like you've done previously, but we also have to balance the charges, and thus we have to balance the electrons. Kind of like how I came up with this 8 and 8 off the top of my head. I'm now going to work out how we can come out with that number. I just presented these very quickly, 8 and 8, but there is an organized way in which we can come up with this and balance those electrons. So the first thing we want to do is, so this is called the half method, and we're going to break this reaction down into two half reactions. Okay? And we break them down into the half reactions based on the atoms. All right? So this one is pretty easy. So I can see I've got a Ce4 plus and a Ce3 plus and a Sn2 plus and a Sn4 plus. So that's going to be pretty easy to break this one up into its two halves. Okay? So I'll write this first half like so. And I'm going to drop the phases just to make this a little bit easier to write. Okay? And we'll put the phases back in at the end. And then I'll write this other half, and I'm going to give myself plenty of space here. Okay? And so now what I first want to do is balance the atoms. And when I look at this, I can see that so far it looks like my atoms are balanced. So I don't need to do anything there, right? There's 1 and 1 and 1 and 1, so we're good to go there. The next thing I need to do is balance the charges. And I balance the charges with electrons. So I've got 4 plus, let's write plus 4 on this side and plus 3 on this side. And I can balance these numbers by saying plus 4 minus 1 makes plus 3. So how do I add a minus 1 in a chemical reaction? Well, I can do that by saying plus an electron, right? So when this ion reacts with an electron, it goes from being 4 plus to 3 plus. Beautiful. What about this half? Okay. Well, if it's plus 2 on this side and plus 4 on this side, then I need 2 minuses on this side, and I can achieve that by saying plus 2 electrons. Okay? So now I've balanced each respective half, and I'm ready to bring them back together. And I'm going to bring them back together by adding them. Just like I can add equations in algebra, I can add chemical reactions in the same way. Okay? But what I want to do to balance this is I have to balance the electrons. Okay? So I've got 2 electrons on this side, but only 1 electron on that side. So I'm going to need 2 electrons in total. And the way that I do that is not just by putting a 2 right here. I have to say times 2 of the entire reaction. Get out of here, antivirus. Okay. I have to multiply this entire reaction by 2. And when I do that, okay, we'll say equals, right? I've got 2 of everything now. Okay? So when I recombine these, I want my electrons to cancel. And what I'm left with for this balanced reaction is 2 of these ions, but we would not have ever expected that just looking at the equation. Okay? And we wouldn't have gotten that because we didn't really know what these oxidation states or charges were before. But now we recognize that because the charges and the electrons have to be balanced, we actually needed to have a 2 in front of that to make it work. And now also, if we think about this for just a second here, if we were writing this reaction as is, right, up here. Look, it's 7 total plus on this side, 4 plus 3, right? And it's 6 total plus on this side. That's how we know this is not balanced. Straight away, if we looked at that and recognizes that the charges have to be balanced too, we would have seen that it was not balanced. So when we put a 2 here and a 2 here, now let's see what happens. So now I've got 2 times 3 is 6 plus 4 is 10. And over here I've got 2 times 4 plus 2 is also 10. All right? Okay. So hopefully you're feeling okay with this example, because I'm going to do, let's see what's coming up next. I'm going to do a couple more complicated examples, okay? And I'm going to walk you through them. It probably means that this lecture is going to go on for a little bit longer than I wanted it to, but that's okay, because we're working through examples, all right?